Exercise 5B, let's have a look here. So domain and range, to put it in a nutshell, domain refers to all the x values on the graph. So you look at the graph and you only visualize the x-axis timeline or number line. You don't care about the y values, you only care about the x values. And I'm going to show you how I do that later, okay? Then you've got range. Range refers to all the y values. In this case here, this is all the y values on the graph. When they ask you for domain and range, you only focus either the x or the y values. Okay, so if I were to say in the example over here in A, okay, if I were to look at this relation, if you're wondering what the word relation means, relation is just simply a set of coordinates. Okay, so you can see here, this is called a relation because I have a set of coordinates, 1, 1, 1, 2, 3, 4, 5, 6, doesn't matter. If you make up any set of coordinates, we call that a relation because there's some sort of relation between x and y. That's it. A function, which is what you're going to learn in 5C, is specific, a particular type of relation. It follows a particular rule. Okay, and I'll talk about that when we get to 5C. But at the moment, relation is simply a collection of dots or coordinates on a graph. So you can make up any dots and you label those coordinates and you group them together. That's called a relation. Okay. Now in this first relation, so S is equal to, what's in this relation? I've got 1, 1, 1, 2, 3, 4, 5, 6. I've got 4 coordinates. Out of those 4 coordinates, if I asked you what is the domain, so the domain of S, you would then tell me only the x values. Now you can list the x values, but then it may take long depending on what I have. In this case, I only got 4 x values. What are my 4 x values? I'm going to use a different color. I've got 1. That's the x coordinate part of the S function or relation. I've got another 1. I've got a 3 and a 5. So if I were to tell you what the domain is, the smallest number is a 1 and the largest number is a 5, and I've only got 1, 3, and 5. Those are my numbers. Okay, so those are my only coordinates for my domain. I would then list them. I say I only got 1, 3, and 5. Okay, where's my range? I'm now only looking at the y values. So what's my y values? Notice I'm using these squiggly brackets. You only use them when you're listing items. So I'm listing. Now let's have a look at the y coordinates. What are my y coordinates here? I've got 1, 2, 4, and 6. Okay, so those are my y coordinates. And I'm like, okay, well, that means I've still got another 1. I've got 4. And I've got 2, sorry, and I've got 6. That's my range. Actually, now that we're on this, sorry, I'm just going to deviate for a bit. Last session, Matt, you asked me what a proper set was, and I gave you the wrong definition for that. I misunderstood the definition, actually, so I'll re-explain it now. When you write a subset, say A is a subset of B, right? And then if you write A is a proper subset of B, the real difference between them is that when it says a subset, it actually has to belong entirely in it. That's what a subset is. What is a proper subset? Proper subset just means that it can't be the same set. So here's an example. If I told you A is 1, 2, and 3, okay? So 1, 2, and 3 as an example. And then I say B is 1, 2, and 3. Or actually, I'll write it differently. 3, 1, and 2. Then you ask, is it true to say that A is a subset of B? Yeah. If I were to draw it, if this is A, well then B is also the same shape. So technically, I would use this symbol and I'd say A is a subset of B or B is a subset of A. Both are true, right? But a proper subset, this would not be a proper subset. So a proper subset would mean that I want it to actually be something like like that. So in the proper definition of it is, it says it has to contain the elements of the subset, and it always has to have one that's not part of the full subset. So here's an example. If I told you B was 1, 2, this is a proper subset. This is where you can say B is a proper subset of A, because this means that B, though it only has 1 and 2, it is missing a 3. Okay, so it doesn't have the entirety. And the purpose of that is just so that we can say that A and B aren't the same sets. They're not the same groups. So by calling it a proper subset, you know A does not equal to B. That's what they're trying to say. Okay, so that was my fault there for giving you the misconception that it had to be a number outside. It had to be a number that's outside of the set, but not, but still within the set. Okay. All right. Now, let's do an example just to get your head around domain and range, and then we'll talk about what implied domain is. Okay. Let's have a look at example 4 here. I'll do a proper video for it, but since this is a class video, let's do this example together. They want you to sketch a graph of each of the following relations. What is relations again? Set of coordinates. Okay? And then state its domain and range. Now, anything to do with circles, you do not need to know this year. So this is a circle, you can ignore B. Anytime you see a square on the X and a square on the Y, that's going to be a circle. So you can ignore that because I haven't taught you circles and you're not doing it next year. Okay, unless you're doing special, then you'll probably know how to do this question already. But avoid anything with an X squared plus a Y squared. You don't do that anymore. Okay, but let's have a look at A. If we were to do A, sketch a graph. I'm just going to quickly do an axis. Here's my axis. I've got -2, -1. So -2 is here, -1's here. So I've got a dot. -2, -1. I've got -1, -1. So it looks like it's here. I've got -1, 1. -1, 1. Oh, it's over here. And then I've got 0, 1, which is over here. Well, no, it's over here. 0, 1. And then 1, -1. So 1, -1 is over here. I'm going to use a different color so we can see the dots I've colored. We had 1, 0, wait, 0, 1, -1, 1, -1, -1, -2, and -1, and then 1, -1. Okay, so I've just plotted the points there. Probably try to rub out this one. There we go. So the points in red are the points that I have. I've got 1, 2, 3, 4, 5. Your job is to find the domain and range. Now the notation that you learned from 5A, how do you write the domain? X element, or technically, yeah, element means a part of. And now you look at the X values. So here, I always isolate it and just look at the X axis. What's my smallest value based on all the coordinates? My smallest value was a -2. So I don't care about the Y values, I'm only interested in the X axis. On the X axis I've got -2. What's my greatest value on the X axis? It's the greatest value that I can have based on these coordinates here. What's my greatest value? 1. Or you can actually order it if you want. You can highlight them. -2, -1, -1, 0, 1. What's my greatest value? Well, greatest value is 1. So when I list this, I would list it as X is an element of -2, -1, 0, 1. Okay, and the reason why I'm identifying them as a list is because these are just dot points. But if I draw a graph, so for example D, okay, we do D. D is a graph now. What is D? We've got, I'm going to write the notation and let's explain what this means, because a lot of us get intimidated when we see this. Okay, let's break the language. So when you see something like this, What is it trying to say? When do we use braces again? It's when you're listing. What am I listing? This. What is this? X, comma, Y in brackets are your coordinates. So they're trying to say, I'm going to list a set of coordinates. So here we go. These are coordinates. In these coordinates, I have an X and a Y that follow this equation. So really, this is a linear equation. It's a straight line. Comma, X is an element of -1 to 2. Notice it's square brackets. Square brackets means including -1 and 2. This is your domain. They already gave it to you. But if I were to sketch it just for you to visualize, here we go, let's sketch it. This is your X and Y axes. You are to sketch a straight line. So going all the way back to chapter 1, this is my equation, y equals 2x minus 1. To sketch a straight line, how many points do you need minimum? 2. You only need 2 points. Best 2 points, find an x-intercept and a y-intercept. Y-intercept's pretty straightforward, we already got it. It's -1. So I'm going to write here -1 as my y-intercept, 0, -1. And then to find x-intercept, how do you find x-intercept again? What do you have to do? Good. Let y equal to 0. So here we go. We got 0 equals to 2x minus 1. Using your algebra skills, add 1 on both sides. Divide 2 on both sides. X equals half. Therefore, my x-intercept must be, when x is half, y 0. Here's my point. Half, 0. Notice I'm not actually even trying to draw it by scale. I'm just putting in the coordinates. Use a rule of a straight line. Y and x. Now, here's a problem. If you just left your answer like that, that is wrong. Why? Because they told me the domain, the x-axis is not infinite. I don't go all the way to the negative, and I don't go all the way to the positive. I can only go between -1 to 2. So that means somewhere over here, I need to cut off the line. The line only stops as soon as it gets here. So I can't draw this part. This part doesn't exist. Because it says I only want x equals -1. So I need to know what that coordinate is. Then they said x is only up to 2. Well, this is half, so 2 might be over here. So I need to chop the line only from here to here is how much of my graph I'm going to have. So let's put in my 2. This is my 2. If we were to now just draw that point, so now I'm going to put the ruler back in again, and I'm only going to sketch from -1 to the 2. That's what my graph looks like. So now let's answer the question. You've got a visual aspect to it. You're trying to say, what is my range? What's my domain? So domain is the maximum, the smallest number of x values you can have, all the way to the largest value of x values you can have. Because I drew a solid line, that means every single number in between -1 up until the maximum value of 2 is included. Okay, so you can see this is my domain. I'm only working, the graph only works on the x-axis between -1 to 2. Don't get confused by that vertical height. We're only looking at the span, the width of it. And it's only from -1 to a maximum of 2. It doesn't stop here. It goes all the way up to 2. That's where it stops. That's my largest x value. So if I were to write my domain, this is how you say it. X is an element of, now notice because it was inclusive, that means this is a nice closed circle, and this is also inclusive, so that's a nice closed circle. So that means I have to include those values. So my x-axis values is from -1 to 2, which makes sense because they already gave you the domain. Right up here. That's your domain. Makes sense. So you didn't actually have to do anything for the domain. You should have just been able to state it. And funny enough, that is going to be a year 12 question. It's a 1 marker, very straightforward. They'll give it to you in the question. And a lot of students, oh, I shouldn't say a lot, but there's about 20% of students who won't be able to get that. And the reason why is because they can't read what the question's asking. They don't know what those symbols mean. So that's what chapter 5 is to get you to read the symbols. And the question will be, state a suitable x value for the graph. Other students will leave it blank because they don't know what suitable x values mean. All it's asking is, which part of the graph that the x values can have? -1 to 2. 1 mark. Okay? Now, the tricky part is to find the range. That's where the skill comes in. So how do you find the range? Now the range is you're only looking at the y values. Now clearly the maximum y value is up here. That's as high as you can go, and this is as low as you can go. It's not the -1. -1 is part of it, but I've got another point that clearly has a smaller y value. Your job is now to find what is this highest y value and what is this smallest y value. Question is, how do you find it? How do you find that y coordinate of this point? I know the x coordinate is -1, whereas over here I know the x coordinate is 2. How do I find that y coordinate?
X with -1.
Yeah, into the equation. They gave you the equation. They said, if you have x, I'll tell you what y is. So here, I'd say, all right, well, apparently, y will equal to 2 times the x, and then -1. I've got my x values. At this point here, x is -1. I just want to know what y is. Sub x equals -1 in. So here we go. Y will equal to 2 times -1 minus 1. That's -2 minus 1, as long as you're not making any negative errors. Y is -3. So now I know my smallest value is -3. What's my largest value? At this point, based on the graph, I can see that when x is 2, I need to find y. Same thing again. Y is equal to 2 times 2 minus 1. 4 minus 1 gives me 3. So when x is 2, I now know this is 3. So what's my range? The range is from the smallest y value you can have, which is the furthest down, to the furthest up. So it has to be from -3 to 3. So if I were to write my answer, it's inclusive from -3. I do include that one, all the way up to 3 inclusive. Notice my notation here. Smallest number is always on the left. Largest number is always on the right. I'm using square brackets because it says I can include it. And that's what makes it tricky. If you're not paying attention to the brackets, you may get it wrong. Okay? And yes, those who are doing the formative task, you may stop now. All right. Let's test your ability to figure out domain and range. If you can do this, it means you're understanding what I'm saying about domain and ranges. So I've picked question 2. You can then work on question 1, 3, and 4 later on once you can sketch the graphs. But let's start off with a ready sketch graph. Here we go. Let's do this together. So we've got another straight line here. Nice thing is they already calculated most values for you. What is my domain? What's my domain? So looking at it, what is the smallest x value to the largest x value? -2 and 2. And you can just look at the x-axis here. We can see this is as far as I can go. This is as large as I can go. So the domain clearly has to be from -2 to 2. Now you need to work out the brackets. Are they inclusive? Do you include the numbers -2 and 2? And how do you know? It's a dot. It's a field dot. If it was an open circle, I'm just trying to find, none of that has an open circle there. But it has an open circle, you have to use an open bracket. In this case, it's a closed circle. That's why I'm going to use closed brackets. That's my domain. What about the range? Looking at the y value, so look at the smallest bottom y value to the highest y value you can have. What would this be? What would it have to be? So looking at the graph, so now you have to look at the y-axis. -1 to 2. And be careful here again. I usually like to draw the lines to help me. So I go from this graph, clearly is my bottom, so I need to find this y value, and then this is clearly my top. I need to find that y value, and I can clearly see it's 2 is my highest value, and this is -1. So that's why I know answers from -1 to 2. Let's try something a bit more difficult then. What about D? What is my domain and what is my range? Domain should be easy. What's my domain? It's R. Very good. Because it can have every number. This is where it's confusing for students. They get used to seeing just dots. You don't have to have dots here. This graph will go on infinitely. If it goes on infinitely, you can imagine the x-axis, there's always going to be a value as part of the graph. Part of the graph, there's always going to be an x value. There's always going to be an x value for it. So as you go on, doesn't matter how far you go, there's always going to be an x value in the positive direction. And then same thing, whatever this x value is, there's a point on the graph. So the graph, technically, can cover infinite x values on the right and infinite values on the left. And clearly in between, every single x value is accounted for. That graph has it. So sometimes I used to teach one of these students who absolutely struggled with domain and range. And this was about probably 3 weeks before the exam that they had in year 12. And the best way I taught him and how he learned it was I showed him, do vertical lines up until you can't. And so he would then sit there and do vertical lines. And I say, does it cross the graph? And he's like, yes. I'm like, good, that one's included, that one's included, that one's included. So if you keep doing vertical lines, if it crosses the graph, it means it's part of the domain. And that helped him understand that's what the domain is. Whereas over here, see when he drew a vertical line, and I'd say, does that touch the graph? He's like, no. I'm like, well, that's not part of the domain. And I'm like, where's the smallest that you can draw? And then he would draw a vertical line here, it's like at -2. I'm like, great, that's your x value. So if it helps, domain is when you draw vertical lines, because that's when you cross the x-axis. And then for range, if it helps you understand, you're actually drawing horizontal lines instead. See, I'm not touching any part of the graph, but as soon as I draw a horizontal line here, I touch the graph. So that value must be part of the range. Okay, so that helps you draw vertical and horizontal lines to see. But we can already know x is an element of R, R meaning any number that you can think of. So positive values, negative values, and 0. Okay, that's what R means. Now, what about your range? So be careful with the range. So again, draw horizontal lines in your mind. What values can my y values be? Because there's a cap. So they can be 4. Clearly it can't be anything more than 4, because if I drew a horizontal line, I get this point. That's great. So 4 is definitely a y value I can have, but I can't have 5. 5 doesn't touch the graph. So it can't be 5. So what can it also be? It can be anything that less than 4. It can be -3, it can be -1, it can be negative something. And since the graph is going to continue all the way down, means I will have infinite negative y values. So if you were to write your range now, how would you write it? Maximum value was clearly 4. So you would have 4 inclusive. How would you write the other side? How would you say that I want all the negative numbers for the y values?
Negative infinity?
Yeah, so it's negative infinity, which means all the negative numbers all the way up until 4, but then do you use a square bracket or open bracket? Open. Don't ever use square. Okay, so infinity is the concept. We don't know what that number is, so you can't definitely say, I know what that number is. You have to use an open bracket because we don't know what it is. Okay, so that's what the range would be. That's what you're essentially doing here. They want you to sketch the graph so it helps you visualize. Avoid doing anything with an x squared plus 4 or x squared plus y squared, because that's a circle. Okay, so if you see any of the squares, don't draw them unless you want to do it on your CAS. You can do that and then you can answer the question. But each and every one of this says sketch. Sketch. Oh, sorry, it doesn't say sketch. They've already sketched it for you. Sketch. Sketch. Method is all about sketching. Method is all about analyzing graphs. Here, you do need to be able to sketch linear equations, quadratic equations, and then again, I guess quadratic. This is why it was important that you knew how to do chapter 3 sketching so that you can analyze the graph. Okay? When you can analyze the graph or you can sketch it, then you can tell me what the domain and range is. If you sketch it wrong, then your domain and range is going to be wrong. That's why it's important that you have to be able to sketch. So chapter 4, those who are getting the algebraic sort of component wrong, that's why you need to build on that. Because then that will make a difference on what your answer is for your x-intercept, y-intercept, and what the domain and range would be. Okay? But that's essentially 5B. Okay, so it's building on the understanding. So you'll understand the concept. You'll know what I mean when I ask what is domain and range, but how do you deliver? It's based on your algebra. Can you sketch any of these graphs here? And then down here, how are you now with square roots? Actually, don't do any of this. Don't do question 7. 7's all circles. Ignore 7. You should be able to do question 8 and then ignore 9. So 8 is what you've just learnt. That's your chapter 4, 4A, B, and C. You need to be able to sketch that graph so then you can tell what is the domain and range. Now, if you're still struggling from chapter 4, and that's okay, then type that in your calculator. Sketch it on your calculator so you can practice the skill of domain and range. Okay, obviously the best thing is that you can visualize what these equations are. So chapter 4 relies on you knowing how to sketch these graphs. Chapter 1 and 2 and 3, that's what this section is. So if you've struggled with sketching in general, well, this chapter will be quite a bit challenge. So that means your SAC will be a challenge. But it's not the theory. The theory is straightforward. It's the delivery. Work on your delivery. Okay? All right, that was 26 minutes of me explaining, but that's exercise 5B. I will make videos separately.